Today's video starts on page 16 in your packet. So this is video 9. Starting on page 16 in your packet. The length of a rectangle is 5 times its width. The perimeter is 60 centimeters. Find its area. I would like you to do this problem of the day question on your own. Give it your best shot. Bar, model this. So draw a model. Give it your best shot, try it, and we'll go over this in class tomorrow. So on to page 17. Additive and multiplicative comparison models. Here's an example. Don's age problem. Farid is 3 years younger than Erica. So you're going to draw his bar a little bit shorter than Erica's and add that little extra 3 years on. Don is 3 times as old as Erica. So take Erica and replicate it 3 times. So 1, 2, 3. So he's 3 times her. How old is Don? So how old is Don? There's your question mark. Rearrange the models to make the comparison of Erica and Farid's total age with Don's age. So Erica, single bar, plus her 3. So this part's Erica and this part is Farid. If you add them together, it's 15 years less than Don. Here, where Don is 15 more than them, so here's the equivalent, as you can see, a Farid, and 3 years for Erica, a Farid, and 3 years. So you can see that Don is 15 years older. So the unit bar is 15, take away the 6 that we already know, gives us that bar would be equal to 9. So Don, if I add this together, 9 plus 9 plus 9 plus another 9, right? 3 and then the 6. 4 times 9 is 36, or 3 times 9 plus 9 more, you get 36 years old. Comparison models involving fractions, ratio, and percent. The sentence, Jack has twice as much money as Katie, could be expressed in other ways. They could say, Katie is half as much as Jack, a fraction. The amounts of money of Jack and Katie are in the ratio, Katie has twice as much, of 2 to 1. There's a ratio. Katie has 50% of Jack. There's a percent. In this section, we're going to draw comparison models for word problems involving fractions, ratio, and percent. First example here. At a fair, there were half as many men as women. So men is 1 bar, women is 2. The number of adults, men and women, was a third of that of children. So children are 3 times the total of the adults, which is 1, 2, 3 bars. You can see there. So 1, 2, 3, 1, 2, 3. So 3 times the men plus the 2 for women, men plus 2 for women, men plus 2 for women. Altogether, there were 3,600 people at the fair. How many children, see the question mark here, how many children were at the fair? So there are a total in our picture of 12 bars. 1 unit would be 3,600 divided by 12, which is 300. So the children represent 9 of them. 9 times 300 would be 2,700 children. There were 2,700 children at the fair. The next example, onions and carrots. 3/4 of the sales from onions is as much as, so 4, we're going to draw a bar and divide it into 4 sections and have 3 of them. This part is not here. Dot, 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 dot. It's really not there because we're only representing 3/4. Is the same as 3/5. So now you're going to draw a bar, cut it into fifths, and 2 of them, as you can see here, are not part of it. The sale from carrots is 250 more, so if you compare them, 240 more than the sale from onions. Find the total sales from the onions and carrots. And this got cut off, so that's the question. How many are there total sales? Well, we can tell that it's only different by 1 unit. So that 1 unit has to be the 240. There are a total of 9 units in the picture. That's the total that we want. 9 units in the picture. So the total sales is 2,160. Next page. The Lee brothers problem. There are 3 boys in the Lee family. The ratio of the eldest boy's age to the youngest, so eldest boy here has 4 bars, to the youngest is 4 to 1. The ratio of the middle boy's age to that of the youngest is 2 to 1, so he has 2 bars. The eldest boy is 4 years older than the middle boy, so only this part represents those 4 years. How old is the youngest boy? So you got to put the question mark here. Well, if 2 of those units, 2 bars, represent 4, one of them would represent 2. So, and that is the youngest boy, so he's 2. He's 2 years old. Pretty easy. The ratio of the number of red pebbles to the number of blue pebbles to the number of green pebbles in a container is ratio. So ratio, order, counts. So red is the 2, as you can see here, right? I'm going to write red, but it's already written there. Blue is 3, and green is 5. So they are in the ratio of 2, order counts, 2 to 3 to 5. That's the ratio. And you can see the bars are drawn there. How many red pebbles are there? Here's the question mark. Altogether in this picture, there are 10 bars. So if I take my 80 and divide it by 10, I get one of them is 8. So 2 of them would be 16. There are 16 red pebbles. So some practice.